Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve the question number 27 of GATE 2022 statistics paper. The problem says that xi is a iid random variables from a normal distribution with given mean 1 and variance 4. So we defined Sn as xn square plus x2 square up to xn square, and we need to find the variance of Sn and the limiting value of variance of Sn by n minus expectation of Sn by n whole square. So given we have xi is our iid and they follows normal 1 comma 4 distribution. So in the first step, let us find expectation of xi square, which is equivalently expectation of x1 square, because xi is our iid. So expectation of x1 square is coming out to variance of x1 plus expectation of x1 whole square. Variance of x1 is 4 and expectation of x1 is 1, and the square is 4 plus 1 5. So we have expectation of x1 square is 5. Now expectation of Sn is expectation of summation xi square I equal to 1 to n, and since expectation is a linear function, it goes inside the summation, and we got summation of expectation of xi square, which is 5 into n 5n. So now we are going to find variance of Sn. So variance of Sn is same as variance of summation xi square, and since xi's are independent, xi squares are also independent, because if x1 x2 are two random variables, then for any function fx1 and fx2 are also independent. So by applying this, we can say that xi squares are also independent. So this variance of sum is coming out to be sum of variances. So since they are identical, and the variance of Sn is coming out to be n into variance of xn square. Variance of x1 square is expectation of x1 to the power 4 minus expectation of x1 square whole square. So expectation of x1 square, we know that is 5, that's square is 25. So we need to find the expectation of x1 to the power 4 only. Now to find this, we will use the MGF technique. So the MGF technique says that for a random variable which has MGF and all the moments exists, so the MGF is the expansion of the power series expansion of this expectation. So this is coming out to be something, we'll get a series from this, and from the definition of MGF we get expectation of x1 to the power r, that is rth order raw moment, is the coefficient of t to the power r by r factorial in the expansion of MGF. Okay, so we use this fact in this problem. So to find expression of x1 to the power 4, we write the MGF of x1 as mt equal to e to the power t plus 2t square, because for normal mu sigma square, the MGF is expectation of e to the power tx equal to expectation of mu t plus half t square sigma square. So putting the values of mu and sigma square, we get this is e to the power t plus 2 sigma 2t square. So by expanding this in the form of exponential function, we get n equal to 0 to infinity t plus t 2t square whole to the power n by n factorial, because expectation of ex as the expansion x equal to 0 to infinity, sorry, n equal to 0 to infinity x to the power n by n factorial. We simply use this notation here, the expansion here. So the coefficient of t to the power 4 by 4 factorial can be found only for n equal to 2, 3, and 4, because for n greater than equal to 4, this will have, sorry, for n greater than 4, that is n greater than equal to 5, we will have t to the minimum power of t will be t to the power 5, which is not required here, because we need to find only the t to the power 4 terms. So from n equal to 2, we get the coefficient is t to the power 4 by 4 factorial into 48. For n equal to 3, this is coming out to be 24. And for n equal to 4, this is coming out to be 1. So as a whole, the coefficient of t to the power 4 by 4 factorial is coming out to be 48 plus 24 plus 1 equal to 73. You can check this by using the by expanding this binomial term. So this will be for n equal to 2, this will be t square plus 2 into t into 2t square plus 4t to the power 4. Okay, by 4 factorial. Sorry, 2 factorial. So from this we get t to the power 4 has a coefficient of 48. T to the power 4 by 4 factorial has a coefficient of 48 because we need to adjust t to the power 4 by 4 factorial here. Similarly, we get 24 and 1. You can check by yourself also. So from 1, we get variance of x1 square is coming out to be 73 minus 25, which is 48. So x, that is expectation of x1 to the power 4 minus expectation of x1 square whole square. So variance of Sn is 48n, because variance of Sn we defined, we got here as n into variance of x1 square, and variance of x1 square we got 48. So variance of Sn is coming out to be 48n. Now the required limit we have, limit n tends to infinity an, that is limit n tends to infinity variance of Sn by n, and expectation of Sn by n whole square. The expectation of Sn is 5n, that divided by n into 5 square, and this is variance of Sn is 48n, that divided by n is 48. So we get limit n tends to infinity 48 minus 25, that is 23. Hence the required value of the limit is 23. So we can write the value of the limit in integer is 23. This is the answer. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.